Hello everyone, welcome back to our channel. Today I am with a new topic, new unit, Electrodynamics. Electrodynamics is also one of the simplest unit in metric in paper 1 physical science. So all can score marks from electrodynamics. There are some tricks to score marks. There are some tricky questions, and if you learn it early, you can score marks. I know all are doing well, all are preparing well. I am wishing you best of luck. So we can start the class. So electrodynamics means it is a relation between electricity, magnetism, and some mechanical properties and some mechanical phenomena. So electrodynamics is something, it relates with the electricity and magnetism and some mechanical phenomena. So in that unit, first I am discussing motor. So some simple questions can ask from this section. First is energy conversion. Energy conversion in motor. What energy converting into which form of energy? So energy conversion in the case of motor. So motor you can see in the grinding machines, something rotate in the fan, so you can see it. So motor converts electrical energy to mechanical energy. Electrical energy to mechanical energy. It is a 1 mark question in some of the metric question paper. So energy conversion in electric motor is electrical energy is converting into mechanical energy. Electrical energy is converting into mechanical energy. Then what is the principle of electric motor? What is the principle of electric motor? It is known as motor effect. Motor effect. The principle used in the motor is motor effect. Motor effect is the principle used in the case of motor. So these are some 1 mark questions, you can get it. There are 2 types of electric motor. Types of motor. First is DC motor. As the name implies, DC motor works with direct current. Direct current you can get from a cell or a battery. So DC motor works with direct current. Which are the main parts? So DC motor works with direct current. Then, which are the main parts of DC motor? First is a coil, or known as armature. Then a magnet. Then carbon brushes. Then splitter ring. So these are the main parts of DC motor: coil, magnet, carbon brushes, split ring. In the case of DC motor and AC motor, these 3 are same: coil, magnet, and carbon brushes. These are same. Only the difference will come here. Instead of split ring, In AC motor we are using slip rings. So in the case of DC motor we are using split ring. So these are the main components of DC motor. DC motor converts electrical energy to mechanical energy. Electrical energy to mechanical energy. So here the main components are coil, magnet, carbon brushes and split ring. So when a diagram, in some question papers, they are giving AC generator, generator and motor. In some question papers, they are giving AC generator or motor, and you have to identify it. So how can you identify a motor? If you are having a diagram, how can you identify a motor? So in the case of motor, there is no external source. There is an external source, that is battery. There is an external source, that is battery. So there is a battery. A battery will be there when you see a motor. When you see a motor, a battery will be there, or an energy source will be there. With that energy source, a motor is working. With that energy source, the motor is working. So when you see a diagram of motor, how can you identify the given diagram is a motor or not, electric motor or not? Check an energy source is there or not, like battery or a cell. So if there is a battery, you can clarify it is as a motor. It is not a generator, it is a motor. So in some question papers, identification, after giving a figure, after giving a diagram, they will ask the given figure stands for generator or motor. If there is an energy source, you can clearly say it is a motor. So what is happening in the case of motor? We are giving electrical energy, and with the electrical energy, mechanical energy is producing. So mechanical energy is forming there. Rotation, it is happening there. So here the new formation is rotation. New formation is rotation. So the coil is rotating. The coil is rotating. That means when a current carrying coil is placed in a magnetic field, when a current carrying coil is placed in a magnetic field, it will rotate. That is the principle, motor effect. So when a current carrying coil is placed in a magnetic field, it will rotate. It will rotate. So the principle, in some question papers, the principle is asking. Principle is motor effect, and some question papers they are asking for the explanation. And here the new direction is the rotation of the coil. The rotation of the coil can be in anti-clockwise or clockwise. Anti-clockwise or clockwise. So Fleming's left hand rule. Fleming's left hand rule is used for finding the direction of rotation of the coil. So Fleming's left hand rule. Direction of rotation is calculated by Fleming's left hand rule. It is very simple. Fleming's left hand rule. Thumb gives the direction of rotation. This is the left hand. Thumb gives the direction of rotation. Forefinger gives the direction of magnetic field. Middle finger gives the direction of current. So you can easily understand like this. A current carrying coil, that is the middle finger. A current carrying coil placed in a magnetic field, it will rotate. You can remember like this. A current carrying coil, that is the middle finger, placed in a magnetic field, that is the forefinger, it will rotate. So that is the working principle of motor. So Fleming's left hand rule, you can remember like this: middle finger, a current carrying coil placed in a magnetic field, that is the forefinger, it will rotate. That is the Fleming's left hand rule. So Fleming's left hand rule is used to find out the rotation of the coil. The coil can rotate in the clockwise or anti-clockwise. So that rule is used for finding the direction of rotation of the coil. Then AC motor. Next type of motor is AC motor. So in the case of AC motor, there will be an energy source. There will be an energy source. So AC, the symbol of AC, alternating current or alternating voltage, this is a symbol. So in the diagram, if it is showing like this, there is an energy source and that energy source is AC, so you can tell it is a motor. Or they will give a battery. They will give a battery energy source plus minus. So if the battery is using, that motor is known as DC motor. If this symbol uses, that is known as AC motor. So anyway, in the case of DC motor and AC motor, there will be an energy source. So that way you can identify it. That way you can identify a motor. So in the case of AC motor works with alternating voltage. So which are the main parts? There is an armature. Armature means it's a coil. Then there is a magnet. Then there is a magnet. Then carbon brushes. Carbon brushes. And last one is slip rings. Slip rings. Slip rings. So that these are the main parts of AC motor: armature, magnet, carbon brushes, and slip rings. So if it is split rings, it is DC motor. If it is slip rings, it is AC motor. So in the case of AC motor and DC motor, there is a magnet. That is a north-south magnet. North-south magnet. And there is a coil. The coil is placed in a magnet. And the coil is connected to the slip rings or split rings. So slip rings or split rings. Okay. So and it is again connected to the carbon brushes. Carbon brushes. And here it is an energy source like this. The energy source can be in this form or it can be like this. So instead of battery, there will be an energy source like this. So both represents the energy source. Both represents the energy source. So you can connect, instead of battery, there can be AC source. So both represents energy source. So when a current passes through the coil, it will rotate in clockwise or anti-clockwise. It will rotate in clockwise or anti-clockwise. If the coil is like this, it can move like this, rotate like this, or rotate like this. So how can you find out the direction of the current? The direction of rotation. Direction of rotation of the coil. So in the case of motor, which is the new thing happening there, the rotation of the coil. You know the direction of current and you know the direction of magnetic field. So how will you calculate the direction of rotation? So depends upon the direction of current through the coil. The rotation of the coil will change. It can be clockwise or anti-clockwise direction. So these are the main components of a motor. A magnet, a coil, it can be a split ring or slip rings, and the carbon brushes. So these are the main components. Then how can you improve the efficiency of a motor? How can you improve the efficiency of a motor? So just increase efficiency of a motor. You can remember like this: I, A, B, N. The efficiency of a motor can be increased by increasing the current, increasing the area of the coil or the armature, magnetic field, increase the magnetic field, or increase the number of turns. So these are the ways you can increase the efficiency of a motor. Increase the current, increase the area of the coil, increase the magnetic field, or increase the number of turns. It can be 2 or 3 mark questions. So it is a simple question, you can score it. It's a simple question, you can score well. So these are the ways to increase the efficiency of a motor. So another question it can come. Suppose it's a coil A, B, C, D. It is placed in a magnetic field, north-south. Only side AB and CD. Only side AB and CD experiencing force. When a current passes through the coil placed in a magnetic field, it will experience force. For a coil there are 4 sides. So only this AB and CD experience force. BC and AD will not experience force. BC and AD, they will not experience any force. So the coil is rotating like this. It is rotating like this or like this. It is not rotating like this. It is not rotating like this. What is the reason? In some question papers they are asking like that. So here BC and AD, they are parallel to the magnetic field. They are parallel to the magnetic field. Magnetic field is from north to south. So BC and AD, they are parallel to the magnetic field. And the field lines are not cutting the sides of BC and AD. The field lines are not cutting BC and AD. They are parallel to the magnetic field. In that case, they will not experience any force. They will not experience any force. So if the sides are parallel to the magnetic field, it will not experience, they will not experience any force. So only the sides AB and CD, they are experiencing force. So the rotation takes place in these directions. In these directions only. Rotation takes place like this way only. It will not rotate like this. So because only AB and CD are experiencing force, BC and AD are not experiencing any force. Why? Why it is so? Because BC and AD, they are parallel to the magnetic field. They are parallel to the magnetic field. So that is a type of questions asking in the metric exam. Next we can discuss generator. Generator, as the name implies, it converts mechanical energy into electrical energy. So conversion it is asking. Conversion is from mechanical energy to electrical energy. That is a conversion. So in the case of generator, mechanical energy is converting into electrical energy. So the questions are giving like this. They are giving a diagram. It can be a motor or a generator. First we have to identify the given apparatus, the given apparatus is a motor or generator. Motor or generator. Motor, how can you identify? There will be an energy source. But in the case of generator, there will not be any energy source. There will not be any energy source. So that way you can identify generator. Generator, if the diagram is given, generator, there will not be any energy source. What type of energy conversion is there? Mechanical energy to electrical energy. Then the principle, many questions it is asking. Principle is electromagnetic induction. Electromagnetic induction. Electromagnetic induction. So many questions are coming like this. Conversion, mechanical energy to electrical energy. Principle, electromagnetic induction. So what is the principle? How can you explain the principle? You already learned in the grade 11. How can you explain it? That means principle, electromagnetic induction. Faraday's law of electromagnetic induction. Whenever there is a change of magnetic flux associated with a coil or a conductor, there will be an induced EMF. There will be an induced EMF. That is the Faraday's law of electromagnetic induction. So all types of generator works on the principle of electromagnetic induction. Electromagnetic induction. All types of generator works on the principle of electromagnetic induction. So that thing you have to keep in mind. What type of energy conversion? What is the principle? Then there are two types of generator. Types of generator. Types of generator. Types of generator. First is DC generator. DC generator. As the name implies, it produces direct current. Direct current. Which are the main parts? Main parts. The armature, then magnet, then split ring, or it is known as commutator. Commutator. And the carbon brush. Carbon brushes. So these are the main parts of a DC generator. Which are the main parts? Armature or a coil, magnet, split ring or a commutator, and carbon brushes. So these are the main parts of DC generator. DC generator gives direct current or direct voltage. So what is happening here? The coil is rotating in a magnetic field. The coil is rotating in a magnetic field. In the case of motor, what is the principle there? A current carrying coil is placed in a magnetic field. It will rotate. A current carrying coil placed in a magnetic field, it will rotate. That is the principle of motor. Here what is happening? A rotating coil placed in a magnetic field, it will produce current. It can be direct current or alternating current. If it produces direct current, it is DC generator. If it produces alternating current, it is AC generator. So that is the difference. So in the case of DC generator and AC generator, the working principle is same. What is the working principle? Electromagnetic induction. Electromagnetic induction. The working principle is electromagnetic induction. So what is the working principle? How can you explain it? Some questions are asking explain it. What is the working principle? How can you explain it? How can you explain it? This way you can explain easily. That means a rotating coil placed in a magnetic field, it will produce current. A rotating coil placed in a magnetic field, it will produce current. The current can be direct current or alternating current. If you are using split ring, you will get direct current. If you are using slip rings, you will get alternating current. So that is the difference. It's very simple to understand. So energy conversion, working principle, and which are the main parts, these things you have to remember. Then the main equation in the case of generator is induced EMF. A voltage is produced. Induced EMF epsilon equal to N delta phi divided by delta T minus N delta phi divided by delta T. This equation you learned in grade 11. N is the number of turns, phi is the magnetic flux, phi equal to BA cos theta. Phi is the magnetic flux. Phi, how can you calculate? Phi equal to BA cos theta. What is B? Magnetic field. What is A? Area of the coil. What is theta? The angle between the coil, the normal of the coil and the magnetic field. If the coil is like this, if suppose this is a coil, this is the normal of the coil, and the magnetic field is coming like this is the angle between them. This is the angle between them. So theta is the angle between the normal of the coil and the magnetic field. Induced EMF equal to minus N delta phi divided by delta T. Delta phi means what? Change in the flux. Change in the flux. Delta T is what? Change in time. So delta phi is produced by what? Delta phi is produced by when a coil rotates in a magnetic field. The magnetic field is a constant. Here the magnetic field is a constant. Then what is changing? The angle. Angle can change. The area of the coil also a constant. So when the coil rotates in a magnetic field, what will happen? The angle between the normal of the coil and the magnetic field always changing. Always changing. And that change gives delta phi. So delta phi is equal to what? Delta phi equal to BA cos theta 2 minus cos theta 1. Cos theta 2 minus cos theta 1. So that gives change in the magnetic flux. It takes place in a time. So that is delta T. So when you take delta phi divided by delta T and multiply with the number of turns, you will get induced EMF. So in some question papers they are asking Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? Whenever there is a magnetic flux change, it will produce induced EMF. It will produce induced EMF, or induced EMF is directly proportional to the rate of change of magnetic flux. The induced EMF is directly proportional to the rate of change of magnetic flux. If there is more rate of change of magnetic flux, more will be the induced EMF. If there is less rate of change of magnetic flux, there will be less induced EMF. So that is Faraday's law of electromagnetic induction. So main parts, principle, energy conversion, main equations. So these things you have to remember. Then rule for finding induced current. Rule for finding induced current. The rule is Fleming's right hand rule. Fleming's right hand rule. It is very simple. Fleming's right hand rule. So Fleming's right hand rule is used for finding the induced current. So this is very simple. A rotating coil. Thumb gives the direction of rotation. Thumb gives the direction of rotation. So a rotating coil placed in a magnetic field. Placed in a magnetic field. It will produce current. So thumb gives the direction of rotation. Forefinger gives the direction of magnetic field, middle finger gives the direction of current. So a rotating coil placed in a magnetic field, it will give induced current. So if you have a diagram, you can find out the direction of induced current. Direction of induced current. So how can you find out the direction of induced current? Suppose this is a magnet, this is a coil, and you have to find out what is the direction of current passing through AB. So you know the direction of rotation of AB. You know the direction of rotation of AB. So keep the thumb in that direction. So for example, this is a coil. If the coil is rotating like this side, these are the two sides. The coil is rotating like this or like this. It will not rotate like this. It is not rotating like this. So the coil is rotating like this. Suppose this side is moving up. So thumb gives the direction of rotation. So thumb gives the direction of rotation. Then if the magnetic field is like this, so through, then what is the function of carbon brush? In some questions they are asking, what is the function of carbon brushes? So carbon brushes maintain the electrical contact with the slip rings or split rings. So electrical contact with split rings or slip rings. If the carbon brush is in AC generator, it is in electrical contact with the slip rings. If the carbon brush is in DC generator, it is in electrical contact with the split rings. So that is the main function of carbon brushes. Then what is another one? It is taking electric current to the outside circuit. It is taking electric current from the to the outside circuit. So through carbon brushes, the current is going outside. So that is the second function of the carbon brush. So carbon brush is used to maintain the electrical contact with the split rings or slip rings. And it can take the input produced in the coil through the slip rings or split ring to the outside circuit. So these are the two functions of carbon brushes. Then another question is asking, how can you improve the efficiency of a generator? How can you improve efficiency of a generator? You just remember like this. NAB or speed. So instead of speed you can tell frequency. So if you increase the number of turns, the efficiency of the generator will increase. If you increase the area of the coil, it will increase the efficiency of the generator. If you increase the magnetic field, if you use a powerful magnet, it will increase the efficiency of the generator. If you increase the speed of the rotation of the coil or the frequency of rotation, it will increase the efficiency of a generator. So it can ask for 2 or 3 marks question. If it is 2 mark question, you must write 2 different points. If it is a 3 mark question, there should be 3 different points. So increasing number of turns, increasing the area of the coil, increasing the magnetic field, and increasing the speed of rotation or frequency of rotation of the coil. So these are the ways you can improve the efficiency of a generator. This side, the current will move like this. through this side, current will move like this. So normally the current will move this side in this direction. So thumb gives the direction of rotation. So this side, suppose in this diagram, this side is rotating upward. So keep the thumb like that. Suppose the magnetic field is from here to here. Keep the forefinger like that. So thumb and forefinger are aligned in the given direction. Then the middle finger is in this direction. Middle finger is in this direction. So the current flowing through this side will be like this. And this side will be like this. So this way you can find out the direction of induced current from a diagram. So there will be questions by giving a diagram. They can ask through along AB, what is the direction of induced current? Along CD, what is the direction of induced current? So that type of questions can ask from AC generator. So we discussed the DC generator. Next, we can go to the AC generator. So AC generator, it is also works on the principle of electromagnetic induction. It converts mechanical energy to electrical energy. Which are the main parts? Armature, magnet, slip rings, and the carbon brushes. So these are the main parts of AC generator. So slip rings, what is the function of slip rings? It allows current to, in the case of AC generator, slip rings, what is the function of slip rings? Slip rings allows to change the direction of current. So before that, you should know what is the diagram for alternating current. This is the direct current. So direct current means the current is only in one direction, that is plus. Direct current. You are getting direct current from the DC generator. So this is direct current, or you can represent direct voltage. So both are representing like this way. So this is a representation of direct current or direct voltage, and the wave will come on one side, that is plus direction. There will not be any wave on the negative direction. So this represents what? Direct current or direct voltage. But when you consider alternating current, or alternating voltage, it can be represented like this: alternating current or alternating voltage. In some questions, they will ask for draw a graphical representation of direct current or direct voltage, or alternating current or alternating voltage. So direct current and direct voltage you can represent as I told you. Then alternating current or alternating voltage you can represent like this way. So from an AC generator you are getting alternating current. So what is the function of these slip rings? So slip rings allows the current to change the direction after half rotation. So after half rotation, what is happening? This is the half cycle. In the next half cycle, the direction of current is changing. This is positive and this is negative. So slip rings doing this. So slip rings changes the direction of current. slip rings changes the direction of current after half rotation. So in some question paper they are asking what is the function of slip rings. So slip rings, one of the function of this slip ring is what? It changes the direction of current after half rotation. Then another function of slip ring is allows continuous contact with the carbon brushes. Allows continuous contact with the carbon brushes. So slip rings, these are the carbon brush. So there will be continuous contact with the carbon brushes. So when the coil rotates, the slip rings always in contact with the carbon brushes. So what is the advantage of that? The current produced in the coil you are getting always outside, or the power produced in the coil you can take always outside. So slip rings always in contact with the carbon brushes. So because of that, the current produced is always you can take outside. There will be no breaking of circuit. There is no breaking of circuit. So which are the two functions of slip rings? Slip rings changes the direction of current after half rotation. Second one is slip ring is always in continuous contact with the carbon brushes, so that the current produced in the coil can be taken outside always without any breaking of circuit. So these are the two functions of slip rings. It is of 2 marks. Many of the questions are asking which are the function of slip rings. Then, so AC generator, DC generator. From a diagram, how can you find AC generator and DC generator? Check the generator. If it is slip rings, it is AC generator. If it is split rings comes like this. Split rings comes like this. It is in contact with the carbon brushes. Split ring come like this. Split rings. If the diagram comes like this, this is DC generator. If the diagram comes like this is slip rings. This is AC generator. So by seeing this, you can tell the given generator is DC or AC, because other parts of the generator are same. They are same. Only the difference is here. Which are the difference? One is using slip rings, that is AC generator. Another is using split ring, that is DC generator. So this way you can identify the two types of generator. It can be a 1 mark question. I saw that question in the previous year question paper. So that way you can identify AC generator and DC generator. Then what is the function of split ring? What is the function of split ring? Split ring, where we are using split ring is used in the DC generator. What is the main function of split ring? It allows current flow in the one direction. So you know that DC generator produces output voltage or output current like this because of split ring. If you are using slip rings, the output is like this. So because of the function of split ring, you are getting current like this. So it allows current to flow only in one direction, that is plus direction. If you use slip rings, the current flows in both directions, plus and minus. After half rotation, it changes the direction. So these are the main function of split ring and slip rings. So you must learn that. So how can you represent alternating voltage or alternating current? Like this. If you want to represent direct current or direct voltage, how will you represent? Like this. This is direct current or direct voltage. Here I am discussing RMS value. RMS value. RMS means root mean square. What is the significance of RMS value? If you have an alternating current like this, what is the average value of this? The average value is 0. What is the reason? If you consider plus 2 here, there will be a minus 2. If you consider plus 3 here, there will be minus 3. So if you take the average of like this, it will be 0. For example, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. If you take the average of this, it will be 0. When you add these, it becomes 0. So the alternating current or alternating voltage you can't measure by taking the average value. Alternating current or alternating voltage you can't measure by taking the average value. So you need another measurement. That measurement is known as root mean square. For example, minus 1, plus 1, plus 2, minus 2. If you take the average of this, it will be 0. But if you take the RMS value, it will not be 0. What you have to do? You have to first square this. That is minus 1 square, plus 1 square, plus 2 square, minus 2 square. Then take the mean value. Plus divide by 4. Mean is divided by 4. Then take the square root. This is the RMS value of these numbers. It will not be 0, but its average value will be 0. But this will not be 0. So alternating current and alternating voltage we are measuring by taking its average value. So how will you measure the average value? So if we have a alternating current or alternating voltage like this. Suppose this is time. Here I am taking current. This is the alternating current. For example, this is 2. 0, 1, 2, 3. Here the maximum current is 2. This is 2, this is minus 2. Here the maximum current is or the peak current. Maximum current or peak current is 2. It can be ampere or milliampere. Or its another name is maximum current. It is represented by Imax. Then, if I am drawing an alternating voltage with the same wave diagram, this is an alternating voltage with the same wave diagram. Time, this is voltage. For example, this is 10. Maximum voltage is maximum voltage or peak voltage. It is 10 voltage. It is represented by Vmax, 10 voltage. So, these are the representation of maximum voltage and maximum current or peak voltage and peak current. Then, how will you get the RMS current and RMS voltage? Vrms equal to Vmax divided by root 2. Irms equal to I max divided by root 2. So these are the very important equations. RMS value of an alternating current or an alternating voltage. How will you get it? Vrms equal to Vmax divided by root 2. Irms equal to Imax divided by root 2. From this equation it is clear. Vrms is less than Vmax. Irms is less than Imax. So it is clear. So these are the two types of current and voltage in an alternating waveform. So from an alternating waveform you can calculate what? Vrms, Vmax, Irms, Imax. So these are the ways to get it. Then you learned P average, which are the equations power I, V, P equal to I square R, P equal to V square divided by R. These equations we are using in the case of direct current or direct voltage. Direct current and direct voltage. But in the case of alternating current and alternating voltage, these equations become P average, Irms, Vrms. P average, Irms square multiplied by R. P average, Vrms square divided by R. So the equations will change like this in the case of alternating wave diagram. Instead of I, Irms, instead of V, Vrms. So these equations you must remember. In South Africa, the voltage produced is voltage is nearly 230 voltage or 240. 230 to 240. So what is the name of this voltage? Is it peak voltage or RMS voltage? It is RMS voltage. It is not peak voltage. So in the questions, if they are not mentioning peak voltage or peak current, they are giving RMS current and RMS voltage. In the question, if they are mentioning only peak current and peak voltage, you can ask directly that. But if they are not mentioning peak voltage and peak current, if they are not mentioning, the voltages and the current are given RMS current and RMS voltage. So this voltage, it is RMS voltage. In some questions it is 230 voltage or 240 voltages. So these are the RMS voltage. So from RMS voltage, how will you get the maximum voltage? Maximum voltage equal to root 2 times Vrms. How will you get the maximum current? Root 2 times Irms. Root 2 times Irms. So from voltage you can calculate current. If the resistance is given, you have the basic equation V equal to IR. If you know the voltage Vrms, how will you get the Irms if the resistance is given? So Irms equal to what? Vrms divided by 4. Vrms divided by R. So by knowing the Vrms, you can calculate Irms by using Ohm's law. So these are the main equations in the alternating waveform. Another equation you can use like this: P average equal to Irms Vrms. So instead of Irms, you can use Imax divided by root 2, Vmax divided by root 2. So it becomes what? Imax Vmax divided by 2. Root 2 multiplied by root 2. It becomes 2. So P average you can use like this. If the values are given directly Imax and Vmax, there is no need of converting into Irms and Vrms. You can use direct this equation. So depends upon the value given. Depends upon the value given, you can use different equation. So main equations are what? In AC waveform, in alternating waveform, Vrms equal to Irms into R. P average equal to I square RMS R, or P average equal to V square RMS divided by R, or P average equal to IRMS into VRMS. Then another equation you can write IRMS equal to Vmax divided by root 2. Vrms equal to Vmax divided by root 2. Then P average, another equation you can use 1 by 2 multiplied by Imax Vmax. So these are the main equations you can use in the numericals. In the numericals, these are the main equations you can use it. So here you can see only IRMS and VRMS is there in the case of alternating waveform. Then different type of questions can ask if the wave pattern given like this. Like this, if it is given, how will you calculate? How will you calculate different quantities if the wave is given like this? This is 0 and this is 0.01 second. This is 0.02 second. 0.02 second. So, for example, this is a voltage diagram. Suppose this is 2. Here voltage, here it is time. So the questions can, in some question papers, different types of questions are asking. For example, how many rotations are in 0.015 second? 0.015 second. This is 0.1, 0.01, this is 0.02, 0.01, 0.02, 0.01, 0.02. How many rotations? How can you calculate it? So this is one rotation. When the wave reaches here, this is one rotation. One wave. This is 0.015 second. So how many waves are there? There is a half wave and 1/4 wave. So the total number of waves become 3/4. 3/4 wave. So this is half wave and 0.015 second is here. So this is 1/4 of the wave. So total wave from here to here, it is 3/4 wave. If the time is 0.02 second, there will be one wave, one rotation, one wave will be there. So if it is here, there will be 3/4 of the wave or 3/4 of the rotation. So this type of questions you can see in different question papers. Then from this you can get time period. Time period here it is 0.02 second. Time period of the wave you can calculate from this. Then from that they can ask frequency. Frequency equal to reciprocal of the time period. So they can ask for the time period of the alternating wave, and they can ask for what? They can ask for the frequency of rotation. Frequency of rotation they can ask. So these type of questions you can see in different question papers. And another thing you have to remember, The frequency using in South Africa, it is 50 Hertz. 50 Hertz. That means 50 cycles are in 1 second. 50 cycles are in 1 second. 50 cycles are in 1 second. So, in 1 second, how many peak voltage or peak current will be there? So, for one wave, this is the peak current. This is also a peak current or peak voltages. For one wave, there are two peak voltage or peak current. So in 1 second, 50 cycles are there. That is 50 Hertz. 50 Hertz means 50 cycles are there. 50 Hertz means 50 cycles are there. In 1 second, 50 cycles are there. In one wave, there are two peak current or peak voltages. So in 1 second, how many peak current and peak voltage will be there? How many peak current or how many peak voltage will be there? 100. 100 peak voltage or 100 peak current will be there. So that type of questions you can see in some question paper. Then, if I am doubling the frequency of rotation, how it will affect the peak voltage or peak current? So, you just remember this equation, peak current or peak voltage depends on number of turns, area of the coil, magnetic field, frequency of rotation. It is directly proportional. If the number of turns doubled, peak current or peak voltage will double. If area of the coil is doubled, peak current or peak voltage will double. If magnetic field is doubled, peak current or peak voltage will be doubled. If frequency of rotation is doubled, peak current or peak voltage will be doubled. So these are the type of questions you can see in different question papers. So you must remember this. Then, which are the advantages of AC over DC? In some question papers you can see 2 marks question. Which are the advantages of AC over DC? Alternating current over direct current. So the production of alternating current is very cheap. It can transmit for a long distance without with less energy loss. Another thing is alternating current can be converted into direct current. Expense is less. So these are the main 3 points. The advantages of AC over DC. First is production cost is less. Second is we can transmit AC over a long distance with less energy loss. Third one is what? We can easily convert alternating current to direct current with minimum cost. So these are the advantages of AC over DC. AC over DC. So another thing I already told you, in the question paper, if they are not mentioning maximum current or maximum voltage, if they are not mentioning it, peak current or peak voltage, if they are not mentioning, the current and voltages are given are RMS current and RMS voltage. So you take RMS voltage and RMS current like that. Otherwise they will mention peak current and peak voltage. They will mention like that. So these are the main things in electrodynamics. You can easily score marks in electrodynamics with simple topics, with the simple points. So you arrange the concepts systematically and study according to the previous question papers and prepare well. You can score full marks. I wish all best to my learners, to my viewers. All should get good levels. What you can achieve, you achieve that. If you can achieve level 7 in physical science, you must achieve. Wish you all success. Thank you for listening.